Welcome to this YSL tutorial. In this video we're going to teach you all about using transactions in Microsoft SQL Server. We'll start the video with a quick look at the basic syntax of transactions, so we'll explain what a transaction is, how you can begin one and then either commit it or roll it back, and we'll also show you how you can create named transactions. Once we've covered the basics, we'll move on and show you how you can actually make use of transactions. So we'll teach you how you can test for whether you want to commit or roll back a transaction using if statements, show you how you can use transactions with error handling code, talk to you about how you can automatically make transactions roll back, or how that feature works, how to create nested transactions, use Savepoints, and finally the most complicated part, how you use transactions within stored procedures. So there's quite a lot to do. Let's get started. In SQL Server, a transaction is like an event which occurs whenever something changes the data in your database. So for example, a transaction occurs when you add new records to a table, when you update existing records in a table, or when you delete records from a table. Each time one of these things happens, SQL Server records that event in something called a transaction log. Now normally when you're modifying data in a database, you don't get the opportunity to control when the transactions happen. To all intents and purposes, when you execute a query such as this one, the transactions take place immediately and the changes are saved in the underlying database. So if I execute this script, I'll see 3 success messages effectively. I've inserted, updated and then subsequently deleted the same film. And all those changes have taken place immediately. If I wanted to undo the changes, I can't. So this video is all about how you can control that process a little bit more carefully by explicitly beginning transactions and then choosing when those changes are committed, or even giving you the chance to undo them. In order to control when your transactions happen, you need to tell SQL Server when you begin a transaction before you attempt to modify any data. So the way that you tell SQL Server to begin a transaction is very straightforward. You write the literal statement, begin transaction. And it's as straightforward as that. In fact, if you're feeling a bit lazy and you don't want to have to type out the full word transaction, you can even get away with just typing in begin tran. Now if you explicitly begin your transactions, SQL Server no longer automatically commits them to the database. So what you also have to do is explicitly commit your transaction, and you can do that in several different ways. After you've made some modifications to your data, what you would need to do is say either commit, or you could say commit tran, or you could say commit transaction. So any of those 3 methods would work. So just to test out this example, if I execute my script now, I'll find that I've added a single row to my database. Of course, that's a fairly simplistic example. The real power in transactions comes from the fact that you can perform any number of actions, make as many changes to data as you like between beginning a single transaction and finally committing it. So there's no limit really to the number of things you can do between begin and commit transaction. Now, as well as choosing to commit a change to the database when you've begun a transaction, you could also choose to undo those changes. So what we have here, we've begun a transaction and inserted a record into a table, and a simple select statement to test that that record is in the table. What we're then going to do is undo our changes, and we do that with a rollback statement. So you can say rollback, you can say rollback tran, or again you can say rollback transaction. If I then try to perform the same select statement once my changes have been undone, what I'm going to see when I execute this code is, for the first select statement, I see the record that I've added, and for the second select statement, I see that it's been removed from the database again. So we've seen how to begin a transaction and then either commit it or roll it back. It's also worthwhile knowing that you can give names to your transactions, and you can do that very simply by adding a label after the begin transaction statement. So I'm going to call this one add Ironman 3, because that's what the transaction does. I can then copy this name, and I can attach that label as well to the commit statement, or if it was the rollback statement, I could add it to the rollback statement as well. So if I execute this script now, it does exactly the same job as though it didn't have a name. It's just that it can make things a little bit more clear. It's not such a great advantage in such a small, simple example like this. But in longer scripts, where you have many transactions that begin and end, having names for them can help you to spot where each one begins. In all of our examples so far, we've either always committed our transaction or we've always rolled it back. Now in the real world, it's much more likely that you will want to determine whether or not to commit or roll back a transaction based on some form of condition. So for this simple example, we're going to add Iron Man 3 to our table again, and we're then going to check how many versions of Iron Man 3 exist in the table. If that's more than one, then we're going to roll back our transaction. Otherwise, we're going to commit it. Now, of course, in the real world, it would be much more sensible to check whether Iron Man 3 exists in the table first, before we attempt to add it, but this is just a quick and easy way to demonstrate how you can conditionally commit or roll back a transaction. So we've declared a variable which we're going to use to hold the number of Iron Men films, I guess, in the database, and we've begun our transaction to add Iron Man 3, and then we've inserted that record into the table. What we'd like to do then is count how many Iron Man 3 films there are in the database. So we're going to do that by selecting, and we're going to use our variable here at Iron Men equals count star from TBL film, where, get that right in a moment, where film name equals Iron Man 3. So at that point, we'll have stored the number of Iron Man 3 films in the database. The next job is to test what the number of Iron Man 3 films is, and we can do that using an if statement. So I'm going to check if at Iron Man is greater than 1. What I'd like to do is a couple of things actually. I'm going to have a begin and an end block in here because there are a couple of actions I'd like to perform. First of all, importantly, if I find Iron Man already existed in the database, I want to roll back my transaction. So effectively undo adding Iron Man 3 to the database. Iron Man 3, there we go. And also it's worthwhile telling the user or the person running the script that this has happened as well. So I'm going to add a print statement. So I'm going to say print Iron Man 3, spell it with a capital M, there we go, Iron Man 3 was already there. If the count of Iron Man 3 films is not more than 1, then what I can do is write an else clause, or add an else clause to my if statement with another begin and end block. And here I can check, I can commit my transaction, commit tran, add Iron Man 3, and then print another message which says Iron Man 3 added to the database. So there's the full script. If I execute this code now once, I should find that Iron Man 3 was added to the database. I previously deleted all the other instances that we'd added. And if I execute the code one more time, I'll find that Iron Man 3 was already there. So I only ever get one instance of Iron Man 3 in my database, no matter how many times I execute that script. So that's a quick look at how you can conditionally commit or roll back a transaction. Rather than using an if statement to check whether or not you should commit or roll back a transaction, in the real world you're probably more likely to do the same thing using error handling. So in this example we're trying to insert Iron Man 3 into our film table again, and then we're trying to update the film director ID of that film to be equal to a string of text. That's going to fail because the film director ID field can only contain an integer. So if I select and execute that code, I'll end up with one action having succeeded, inserting the record, but the second one having failed. What that means is I'm left with a half-completed record lying around in my film table, so it's Iron Man 3 with no film director's ID. What might be a more sensible solution would be if either of these two actions fail, roll back to the beginning of the entire procedure so that I'm not left with these half-completed records. Before we do this, it's worth noting that you don't have to write error handling code to make this system work. There's a default auto rollback feature in SQL Server which works like this. If I begin a transaction, so begin tran add im, and then after I try to update my record, commit tran add im, if I attempt to run this code, I'll see the same sort of error messages I saw earlier on. So I have apparently one action succeeding, one row affected, so I've inserted a record, and then the second one having failed, where I try to insert a string of text into an integer field. However, if I attempt to select Iron Man 3 from this table, so I should find there are two instances, really, if I've successfully inserted them both, I'll still find that I'm only left with the one that I created in the original running of this. So because one of my two actions failed between beginning and committing my transaction, SQL Server by default automatically rolls back the entire transaction. The disadvantage, of course, with having this basic system is that all you end up with are the horrible standard built-in error messages. With error handling, we can control this process a bit more and present the user with much more useful information, so that's what we're going to do. So, to add some error handling to this procedure, let's make a bit more space first of all. What I need to do is tell SQL Server that I'd like to try to perform some actions, and I tell SQL Server that by adding a begin try statement. After I've tried to do some things, I then need to end my try block. Oops, beg pardon, that was supposed to be on a new line. Let's try that again. There we go. So there's my end try. And let me just indent these lines as well to make it a little bit easier to read. So I'm going to try to do all of these things between begin try and end try. If any of those fail, I need a catch block to tell SQL Server what to do. So your catch block begins immediately after your try block ends. So I can say begin catch. My catch block ends, of course, with end catch. And in between these two lines, I simply write all of the instructions that I'd like to be carried out should any of these fail. So let's do a couple of things. Let's rollback tran add im. And then let's print a message to the user as well. Print adding Iron Man failed, check data types. This would be a slightly more sensible and more useful error message in the real world, of course. This is purely for demonstration purposes. So, if I select all this code from begin try to end catch and execute it now, what I will see is hopefully more useful messages appearing. So adding Iron Man failed, check data types. If I were to modify the film director ID, let's make it a number, let's make it an integer. I can't remember what number Shane Black is. Let's use the number 4 instead, which happens to be the ID for Steven Spielberg, but never mind, it will do for demonstration purposes. And if I execute all this code one more time, I'll find this time that my code has worked, I hope. And if I select my records from the film table, where Iron Man 3 exists, I ought to find the original one that I left in there earlier on, and the new one that has successfully been added with a new director ID number. I've just realised that I've actually accidentally updated the IDs of all the Iron Man 3s, so all the Iron Man 3 films will be directed by Steven Spielberg now. But hopefully that demonstrates the error handling section. If I deleted all of the Iron Mans from the film table in the first place, and then run this code again, first of all with it working, with an ID number, that one creates a sensible record in my film table. However, if I tried to set the director ID to be a string of text, and I tried to run this one again, this time I get a nice sensible error message telling me exactly what had happened. So I'm left with only my original working version of that record. So far, all the examples we've looked at have involved just a single transaction, but it is possible to have more than one transaction opened at the same time using a technique called nested transactions. So here's basically how they work. Each time you begin a transaction, the number of transactions that are open increases by 1, and you can actually find out how many transactions you have got open by printing the value of a global variable called @tran_count. So if I were to execute this simple script, which doesn't even in fact do anything, all I'm going to see is that I get a transaction count of 1. What I can do inside this transaction is actually begin another one. So if I begin tran, I'm going to get an inventive name, tran2, and then print at tran count, and yes, commit tran2. When I execute this code now, I'm going to find that I get transaction count 1 and then 2 for each transaction that I've opened. After I've committed a transaction, that decrements the transaction counts by 1, so I can print tran count again in between committing transaction 2 and committing transaction 1. When I execute this, I'll get 1, 2, 1. So you can clearly see that internally SQL Server keeps a record of how many transactions have been begun. So every time you begin a transaction, it increases the transaction count by 1, and each time you commit a transaction, it decreases it by 1. What happens when you start to roll back transactions? Now, when you're doing this with nested transactions, you have to be very, very careful about what you do. First of all, if I were to try to roll back a nested transaction, so an inner transaction with a name, I'll find that I'm not allowed to do so. When you roll back an inner transaction, you're not allowed to specify the transaction by name. If I tried to execute that, I'd get an error message. So let me remove the name from my inner transaction. Now at this point, I'm going to try to execute the entire script in one go. And what I'm going to see are a couple of slightly odd things. First of all, obviously there's an error message there, and I'll explain that in just one moment, but can you first of all notice the transaction count? When I begin a transaction, it increments it by 1, and then begin another transaction, I've got 2 transaction counts. Whenever I roll back a transaction, this isn't related to just the inner nested transaction I'm talking about. When you roll back, everything is rolled back. So when I come to print the transaction count here, I've got 0 transactions open, and hopefully that explains why the commit transaction line here, number 15, has failed, because if all my transactions have already been rolled back, then I can't commit a transaction because there are none open. So that's one thing to be very, very careful with rolling back nested transactions. The other problem with nested transactions and rollback is a little less easy to spot. But if I can quickly show you what the issue is. If I try to reverse what I'm doing here by committing the inner transaction and then rolling back the outer transaction, when I execute the code, everything appears to work normally. So I've started one transaction here, my transaction count is 1, and then I've got 2 transactions open here, transaction count is 2, committed the first one, which decrements my transaction count to 1 again, and then I've rolled back the outer transaction. Now the problem with this is, although it looks like what I've done is saved my actions in the inner transaction, so by committing it I've automatically updated and saved whatever I've done, when I get to rollback, rollback doesn't just undo the outer transaction, it rolls back absolutely everything that happened since the start of the outer transaction. So although it looks as though I've saved my work here, those changes have been undone by this rollback. So we've seen that when you roll back a transaction, it rolls back every open transaction at the same time. But you can give yourself the opportunity to roll back just part of a transaction using something called a save point. So what I'm going to do here, rather than trying to begin another transaction within the first one, I'm going to save my tran at this point, and I'm going to give it a save name. I'm just going to call it save point, something short and simple. When you save a transaction, it doesn't actually begin a new one. It just saves all the things you've done up to that point. It's like a label that you can get back to by using a rollback statement. So if I roll back my tran and I give it the name save point, what this will do is revert back to the changes that were previously saved at this stage. So when I execute this code, you'll see that the number of transactions I have open at any one time is always just 1. So I've managed to roll back whatever I've done between this point and this point, and then committed the overall transaction right at the end. Now you're most likely to see save points used, and in fact this is where Microsoft intend for them to be used, when you're using transactions within stored procedures. So what we have here is a basic script, which is trying to insert, yet again, Iron Man 3 into our film table, and we have an overall transaction that we begin at the start and then commit at the end. So we insert the film record into the film table, and then we try to find the director's ID for for the film by calling a stored procedure, which returns an ID. We then update the film table to add the recovered director's ID into there and then commit the final transaction. Now in the stored procedure itself, which I'll show you the code that was used to create it, we're doing quite a bit more work. So a simple stored procedure which accepts a single varchar parameter. So we pass in the director's name, Shane Black, and then within the stored procedure itself we have an ID variable which can hold an integer. Before we do anything within the stored procedure, we set a save point called add director for the overall transaction. So when we then insert a record into the director table, so we're going to insert Shane Black regardless, and then we try to find out whether or not that director exists more than once. So this if statement checks. If that director's name returns a number of records that is more than one, then we know that the director already existed. So we print that statement to the user and then roll back the transaction to the save point. So rolling back to a save point, remember, doesn't roll back every open transaction, it only rolls back to this specific position. So that will effectively remove Shane Black from the table if he already existed in it. I know it's not the most sensible way to do it, but again, this is just purely for demonstration purposes. Finally, what happens is that our stored procedure returns the ID number from the director table for the director we've just added, and then returns that to the calling procedure. So we should now be able to test out whether all of our code works as intended. I've got a bit of test code here. Let's make sure first of all that neither Ironman 3 nor Shane Black exist in their relevant tables. So we can delete any records if they already existed, and they didn't. If I go back to the main procedure then, and I execute this code, hopefully the first time it works, I'll get both Ironman 3 and Shane Black added to my appropriate database tables. So if I go back to my test code now, and I try to select the relevant records, I've got Shane Black at ID number 131, and Ironman 3 with film director ID number 131. Now that Shane Black already exists in the database, what I should find, however, is if I try to execute this code again, so the main calling procedure, that although I've added Ironman 3 again, I found that the director already existed, so that must mean that he was rolled back. So that should mean that if I go back to my test code, although I'm going to have more than one Ironman 3, I should still only have one single Shane Black, and he should still be the number that's 131. So if I execute this code to select it, that's exactly what I have. So there we go, there's a bit of how save points were intended to be used, is when you're creating procedures which call other procedures and you want to potentially roll back just parts of an overall transaction. If you've enjoyed this training video, you can find many more online training resources at www.wiseowl.co.uk.